Okay, Calc, this is the second half of 6.6. This is the last section of the chapter. Um, we did the trapezoid rule for numerical integration in the last video, and I just kind of want to summarize that just a little bit again. This trapezoid rule, and then what we're going to do in this video is the Simpson's rule. Both of these are used when you cannot find the antiderivative of a function. Most of the time you should just be able to do the 1 over n plus 1 x to the n plus 1 or use substitution. But when neither of those two things work, you have to use one of these, the trapezoid rule, the Simpson's rule. Now this one was one that we could do with substitution. We actually did that. I did that on a separate sheet of paper here, so we do know what the exact antiderivative should be. This is the exact answer. So we're going to compare that with the answer that we got for the trapezoid rule, and we're going to compare that with the Simpson's rule and kind of see, which one in this particular case works better, okay? Sometimes with different functions, the trapezoid rule will end up being more accurate. Sometimes the Simpson's rule will be more accurate. And it's just one or the other, and it kind of depends on what type of function you're talking about. So trapezoid rule is separating him into trapezoids. The Simpson's rule, they don't have a diagram for, but this is kind of how the Simpson's rule breaks down. So similar to the trapezoid rule, you're going to have that b minus a, but instead it's divided by 3n, okay? And same thing as what you're doing with the trapezoid rule, you're plugging in the values, except your coefficients are 1, 4, 2, 4, 2, 4, dot, 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 4, 1. Okay, those are what your coefficients will look like. Instead of 1, 2, 2, 2, 2, 2, 2, 2, 2, 2, 1, it's 1, 4, 2, 4, 2, 4, 2, 4, 1. And this only works if you are doing an even number of separations. So like for the trapezoid rule, we were doing 4 here and 8 here. We were separating him into 4 trapezoids and 8 trapezoids. And really we could have separated him into 3 trapezoids or 7 trapezoids or something like that. But the Simpson's rule will only work if you are doing an even number. So we can only do 4, we could only do 8, we could only do 6. We could not do 5, okay? Just because of the way that the coefficients are set up, okay? So they're wanting us to compare the results for n equals 4 and n equals 8, just again like we did before. So when n was 4, we were starting at 0 and we were going to 1, because that's what this tells me right here. I'm starting at 0 and going to 1. So if I'm sectioning them off into 4 pieces, okay, the first one is going to be 0.25, then I have 0.5, then I have 0.75, and those are going to be the 5 numbers that I'm going to end up plugging in, okay? When my n was 8, I'll make them a little bit longer here. Here's 0, here's 1, half, 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 half. Okay, so right here, this would be 0.5. 0.25 would be here. 0.75 would be here. Okay, and then these ones in the middle here. This is going to be 0.125, 0.375, 0.625, and 0.875. That's what those guys will be. Okay. And so notice again, you can really kind of see the way that I have this set up, that this number and this number and this number, they all end up coming down into the same position. But when we were doing 8 now, we have 4 more that we're adding, okay, into the middle there. So let's just go ahead and set up our Simpson's rule. We have b minus a divided by 3n, okay? So kind of figure out what that would look like. B minus a, b is going to be 1, a is 0. 3n, n is going to be 4. So basically I'm going to have 1 over 12 is what my numbers are going to be here, okay? And then I'm going to have 5 numbers separated in the inside. 1, 2, 3, 4, 5, okay? And the coefficients are 1, 4, 2, 4, 1 in this case, and I'm going to multiply those by what I get when I plug each one of my values in. Okay, this is kind of a cumbersome and kind of a tedious process, but again, this is what you use as a last resort when nothing else works. Okay, so it is kind of a last resort type thing. Okay, so what I want to do is I'm going to use these 5 numbers, 0, 0.25, these ones here. and I'm going to take those and I'm going to plug them into the original, just like we did on the front side, and that's what's going to go in each one of these blanks, okay? So 0 goes in first. The square root of 0 plus 1 is the square root of 1, and the square root of 1 is just 1, okay? We did this all on the front side. 0.25 plus 1, this will be the square root of 1.25. This guy will be the square root of 1.5. This guy will be the square root of 1.75. The writing's really needed to be bigger. This guy's going to be the square root of 2. Okay, so then I'm going to multiply that all out and see what I get. And now I need my calculator. Hold on. Okay, so I'm going to start with the stuff that's inside the parentheses first. 1 times 1 is just going to be 1. So then I'm going to do plus 4 times the square root of 1.25 plus 2 times the square root of 1.5 plus 4 times the square root of 1.75, and the last one plus 1 times the square root. I really didn't need that 1 in front there, but that's okay. Times the square root of 2. And that number is, this whole thing is 14.6273. But then I want to multiply that by 1 over 12, or basically take this number and I'm dividing by 12. And I get 1.21895. We'll go a bunch of decimals out, okay? So that's what I get for 4 of them, separating them into 4 pieces. Now when I'm separating them into 8, let's see what that will look like instead. So still b minus a over 3n, 1 minus 0 over 3 times 8 now instead. And now I have all of this junk here. I'm probably going to end up having to go on to 2 lines. Okay? So 1, 2, 3, 4, 5, 6. Okay? If I'm separating it into 8 pieces, think about how many little blanks that I'll have to fill in. 1, 2, 3, 4, 5, 6, 7, 8. I will have to have 9 of them because of the start and the ending one. Okay, there's going to be 8, or including 0, including 1, there will be 9 numbers that I'm going to have to plug in. So coefficients are still 1, 4, 2, 4, 2, 4, 2, 4, and 1. Okay, now, the one bad thing about the Simpsons rule in comparison to the trapezoid rule, okay, over here we were able to kind of cheat a little bit because I said that the ones that are here in green were the same as the ones that we used up here. So all we would have to do in addition to those would be to add these guys in there. We could take this already existing 9.7455 number and just add these other 4 in there. But the problem is here, when I'm doing this, okay, this guy would come down in this spot. This guy would really come down in that spot. Oh, hold on, let me go back up. This guy would come down in this spot. This guy should come down in this spot. So this one right here should be the square root of 1.25, but notice that the coefficients are now off, right? Because we're alternating the 4s and the 2s, this coefficient was 4 to begin with, now it's 2, okay? So that does complicate things a little bit, okay? So this guy's going to be the square root of 1.5. This guy is going to be, let's see, let's skip one. This guy is going to be the square root of 1.75. This guy is the square root of 2. Okay, and then I'm going to add in my additional ones. Oh shoot, there should be a 1 here. Okay, so now I'm going to add in my orange ones that need to go in between those two, and those all have coefficients of 4. So this guy will be the square root of, if I plug 1.25 into here, 1.25 plus 1 will be the square root of 1.125. This will be the square root of 1.375. The square root of 1.625, and the square root of 1.875. Okay, so this one's kind of a little bit more tedious because I have to type in all my numbers now again. Okay, so first number is 1 plus, then I have 4 square roots 1.125 plus 2 square root 1.25 plus 4 square root. I really hope I don't mess any of this up because this is a lot of numbers to have to retype. Plus 2 square root of 1.5 plus 4 square root 1.625 plus 2 square root 1.75 plus 4 square root. Oh my gosh, we're about done yet. 1.875. Ah. And the last one is the square root of plus 1 times the square root of 2. That's what he is. Okay, and he is, oh, finally, 29.25 and some change, whatever that is. But then we have to make sure that we take that times. This number out in front will be 1 over 24, okay, or taking that 29 and dividing by 24. And you get 1.21895. Okay. All right, so let's look and see. We know what the exact answer should be. Okay, and looking at our numbers that we got here and comparing them to what the exact should be. I'm going to zoom out a little bit. Okay, this is what our exact should be. This is what we got with Simpson's rule for 4. This is what we got with Simpson's rule for 8. Okay, now of these two, the Simpson's rule for 4 and Simpson's rule for 8, which one should be more accurate? Okay, always the one with 8. If we did 16 instead, the 16 would be more accurate. It's always the more that you do, the more accurate it becomes, but it also becomes more of a pain in the butt to have to do that many. So this one's going to be more accurate, and it is really pretty close, right? This one is like exactly on. I don't know what the decimal number would have been after this. Maybe it was a 1, maybe it was, I don't know, 0.9 or something like that, but these two answers are pretty well spot on. This one, the 4 would have rounded up to a 5, so we're pretty close. I would say that for this particular problem, or for this particular equation, the Simpson's rule actually worked better than the trapezoid rule, just because my numbers over here were a little bit different than that. This was 1.21819, and this was like 7.6 or whatever, so you know, we're a little bit off there, but so Simpson's rule in this particular circumstance actually worked better than the trapezoid rule, but that won't always be the case. Okay, Simpson's is not always the better option versus the trapezoid rule. It's kind of touch and go which one is which. Okay, and there's no distinct way of determining which one you should go with. Okay, so again, trapezoid rule, Simpson's rule. Those are what you use when there is absolutely no other method. Okay. There is talking about errors down here that occur with the trapezoid and Simpson's rule because they are not exact. I'm not going to go through that with you. I kind of skip over that every year, but yeah, it's just good to know the final option that we have when nothing else works, and that's these two different methods. Okay.